This is an obvious acid because it starts with hydrogen. That's a good indicator. Not always the case, but usually. Hopefully you recognize we have a polyatomic in there. If we crisscross in reverse, of course there's one there. That tells us the charge of this is 3. This is phosphate. It has a charge of 3 minus. Probably a good polyatomic to memorize. It's common enough in real life and in AP chemistry, they could possibly expect you to know its charge of 3 minus. You might also want to remember the name of this. If it is phosphate, then we change the acid name to ic, and so this is phosphoric acid. This is a polyprotic acid. Poly many, protic protons. So this has more than one proton, and it's going to dissociate in multiple steps. Now our first step, when it loses that first hydrogen, remember, we need to balance the charges, so if this has a positive, this is going to have a negative. And so it's going to release a hydrogen, and it's going to have an anion left as well. Now, if this was given to you as a problem, they would tell you the Ka's. And this comes from the book on page 651, so it's not in the problem, but there's a table right next to it. And the Ka for this, the first step, the first hydrogen it loses, is this. So the first step is no different than any other acid. We have a 5 molar concentration, and so we can ice it up. And so I'm going to start off with 5 moles of this, none of this, and none of this. This is going away. It's going down by some amount. This is going up by some amount. And we can solve this in the normal way. We can do the Ka. We have our x squared on the top, x times x. Again, we can drop this negative x, and we can solve. And so that's a relatively large number for these types of problems. But now, sometimes, they might ask us for something else. We just figured out the concentration of H. We also just figured out the concentration of H2PO4. Let's take it another step, though. What's going to happen with H2PO4? Well, we can figure if that is going to lose a second hydrogen, and when we have a polyprotic acid, that's kind of what we're talking about. Many hydrogens, many protons lost stepwise in steps. So if that loses a second hydrogen, well, then it leaves behind. And we need to balance, again, the charges. This has a -1 charge over here, and to balance it, That would give that a 2 minus charge. Now the Ka for this second step is different than the Ka for this first step. Our second Ka, and let's call this Ka2. Now each subsequent Ka is going to be significantly smaller. Now that's important because if we're trying to find pH, and this gives us some H and this gives us some H, we know by now, because this one is so much smaller than this one, this is not going to affect the pH. It's too small. So if they just asked us for pH, we could stop here and we don't have to go any further. But sometimes they're going to ask you for maybe this value here or this value here. So let's go ahead and work this out one more step here. And again, we'll just ice it up. But now we have to do a little thinking because we don't have our starting 5 molar solution. How much H2PO4 are we starting with? Well, we calculated it up here. And so in the beginning, my initial, I have and my initial hydrogen, well, I also have the same amount because that's what I start with up here. Now this value is not known. Now again, some of it's going to dissociate, but it's going to be so small, we're not going to worry about the change. So we're not actually going to do change in equilibrium. Let's just solve for Ka as it is. So I'm going to do my product. Times my unknown. Divided by my reactant. Since these are one-to-one coefficients, that's going to cancel out. And my HPO4 is going to be equal to Ka sub 2. And I probably should have wrote that there in the beginning. And again, this comes from up here. And so again, this question on my slide doesn't ask for this value, but the book problem it did. And on the test, they could ask for both of those things. All right, so there's the value of this if they asked for this. Going back up here, I never did solve for pH. But of course we can do that. We're going to plug in the H, which we just figured out. And that'll give us the pH.